Okay, folks, so now that we've discussed atomic radius, it should be an easier jump to understanding this probably brand new term, electronegativity. Electronegativity is how much an element pulls on its electrons. You can think of this similarly to a magnet. How much is that nucleus pulling on its electrons? So electronegativity decreases down a group. So decreases as we move from top to bottom. Why does this make sense? Well, I want to compare this to what we were just learning about with atomic radius. So remember, in atomic radius, we have the radius getting bigger and bigger and bigger as we move down the periodic table. Remember, these pictures are showing how big the orbitals are, so the electrons are in a larger and larger and larger space. Now let's relate this to electronegativity. How much is the nucleus pulling on those electrons? Well, if electrons down here at the bottom of the periodic table are far away from the nucleus, they won't feel as much pull. So electronegativity, how much an element pulls on its electrons, depends on the size of the atom. As the element atomic radius increases, the distance between the nucleus and electrons increases. Therefore, pull decreases since they are farther away. An electron doesn't feel the pull as much if it's very far away from the nucleus. What about as we move across a period? Electronegativity increases as we move from left to right across a period. Why does this make sense? Let's again relate this to atomic radius. So we just learned that atomic radius decreases across a period because we get more and more charge. So that charge kind of pulls the electrons into the nucleus. So you can expect then, if that more positively charged nucleus is pulling on those negatively charged electrons as we move from left to right, then electronegativity should behave the same way. For example, if fluorine up here is on the right side of the periodic table, that means its atomic radius should have been getting kind of smaller. Since it's more positively charged nucleus, you should be able to pull more strongly on the negatively charged electrons. Fluorine is actually the most electronegative element on the periodic table. It is doing the best job at pulling on its electrons. So electronegativity increases across periods because let's try that again. Because atomic radius decreases, So the nucleus pulls more strongly on electrons that are close to it. And that wraps up our discussion of periodic trends. So today we talked about how electrons fill the orbitals. They go from low to high energy, and then we talked about s orbitals and p orbitals and how we can use the periodic table to kind of understand what electrons are being filled where. Then we discussed atomic radius, how big an atom is, as well as electronegativity, how much pull the nucleus has on its electrons. And with that, I'll leave you with this cat meme. See you in class.